categorical. So if they are categorical variables, how can we find the relationship? So when we work with categorical variable, we use two-way tables. And we use these two-way tables to find the relationship between two categorical variables. So when we use two-way tables, again, a table that has two ways. One, you look things row-wise, and the other, when we look the data using column-wise. And again, when we are using rows and columns, we are making a table, and we call it a two-way table. When we take two-way table, or when we work with two-way table, we work with two kinds of distribution, marginal and conditional distribution. Marginal distribution, we talked about it last time. When we work with the margins of the two-way table, we use marginal distribution. Marginal distribution does not tell us anything about the relationship of two variables, but it can tell us about the margins or the total with the grand total. And we use the example, this was the example that we used in the class to describe the marginal distribution. When we have a two-way table, first we create an extra row and extra column. Once we create this extra row and extra column, now we are working with the margins of this two-way table, so we do not need this. So we are just using this extra row value, this extra column value for female, and then this is the total. So when I add 2,367 with 2,459, I will get this value. Or I can say that when I add 194 plus 712 plus 1416 plus 1412 plus 1083, I get this. So the sum of row total and sum of grand total is your joint total, or you can say grand total, or your joint. So it is the joint of all the rows total and the column, all the column total and the rows total. So when we work only with the extra row and extra column that we created, the total one, we are working with marginal distribution. And think of marginal distribution as we work with the margins. The margin can be from the column or from the row. Let's say if I'm looking for what is the percentage of females overall. So if I'm looking at the females, so first of all, I need to know 2,337, that many females I have, and how many total, the total observations are this. And similarly, if I'm looking for how many subjects have almost no chance of getting rich out of total, almost no chance of getting riches, that many people, 194, and how many were surveyed, this much, and then you can find that. And again, it says that how many young adults were surveyed. So total, when you look at the sum total of the rows in the columns, this will give you the number of people that were surveyed in that particular table. Questions about marginal distribution. And here the definition: marginal distribution of one of the categorical variable in a two-way table of counts is the distribution of value of that variable among all individuals described in the table. And again, when we talk about marginal distribution does not give us the relationship between two categorical variables. If we want to find the relationship, we need to work with categorical variable. And when, we need to work with conditional distribution. So two categorical variable, if you are looking at the relationship, we use conditional distribution. And again, the word conditional has the word condition in it. So some kind of a condition is applied, and we are looking for that particular condition depending upon if I am looking for from the overall, if I'm looking for just one column, sum of one column, or sum of one row. And when we do the example, it will make more sense. So marginal distribution tells us nothing about the relationship between two variables. for that, we need to explore the conditional distribution of the variable. So conditional distribution, first thing we need to work with the marginal distribution. If I have a two-way table, first of all, I need to create an extra row and extra column, or you can call that as I need to make the margins. Once I make that margin, so this is your total, and then total, and this is your sum total, sum of all the rows and all the columns. So once you make the marginal distribution, or you use a two-way table, create a marginal distribution. Now, when you work with conditional distribution, marginal distribution, I said that we are not going here, here, here. We just work with the extra row and extra column that we created. But for conditional distribution, we need to go inside this or this, and we call them cells. So we need to go inside a cell depending upon what condition is given to me. And then I will see that once I am in this cell, what is my condition? Am I looking for this total or this total or this total? So I have three options. So my denominator in marginal distribution, if you notice, the denominator is always this. And the numerator comes from the margin, either here, here, here. But when we talk about conditional distribution, your numerator comes from the cell. It is coming from inside a cell, and your denominator can be that particular column total, particular row total, or the sum total, depending upon what condition you are working with. So in your marginal distribution, let me just draw marginal distribution here also. And this is your total, and then this is your sum total. So when we work with the marginal distribution, your numerator comes either from here, 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 or here. But your denominator is always this. But when you look at your conditional distribution, in marginal distribution, we do not use these. So marginal distribution, you are not going inside the cell. You are just working with the margins. But in conditional distribution, you are using your cell. Cell is your numerator. Your numerator or your top comes from the cell, either here or here or here or here. But your denominator is not only the grand total anymore. It can be either this or this or this or this, depending upon what condition you are working with. So let's read what is given to us. A conditional distribution of a variable describes the value of the variable among individuals who have a specific value of the other variable. So if my x is this, what is my y? So if my first category is this, and I'm talking about this is my explanatory variable, what is the related response variable? Think that way. So you are looking for the specific value for another variable. And how to find that? Select the row or column of interest. Use the data in the table to calculate the conditional distribution of the rows or columns. Make a graph to display the conditional distribution. Use side-by-side graph or segment. And again, when we read this wording, I don't know how many of you get this, what actually it's explaining. So let's do an example to make more sense out of it. So we are using the same example that we use for marginal distribution. And look at the example. Calculate the conditional distribution of opinion among males. And I'm examining the relationship between gender and opinion. So now you're talking about the relationship. And again, when we are talking about the relationship, we are talking about, first of all, we are looking at the relationship using conditional distribution. So first, it says that calculate the conditional distribution of opinion among males. So we are talking about males and opinion, and these are all the opinion. almost no chance, some chance, 50-50, good chance, and almost certain. So how to find that? So when I'm looking, think of this as a two-way table, male. If I'm talking about this cell, 98, where is this 98 coming from? Male and almost no chance. So that is the total male that says that there is almost no chance of getting rich. And then when we are talking about this, how many males were there altogether? So if I'm looking for the percentage of males, and it says that among males. So when I'm looking at the conditional distribution of opinion of the males, first of all, I need to know how many males. So for how many males, I know that there are 2,459 males. So what is the percentage of males saying almost no chance? Almost no chance, 98. And how many total? 2,459. So I can find the percentage of males who are saying that almost there is no chance of getting rich. So 98 divided with 2,459, you get 4%. Similarly, you can find for this 286 divided with this, 720, this. So you see, we are going inside a cell and then dividing with the margin and margin of the row, margin of the column, because it says that among males. If it says among all, then I will divide with this. Or if it says among the total people who says almost no chance of getting rich, among total people who say almost no chance of getting rich is 194. So again, I have three options, either this or this or this. But the question is asking me only among males. So I am going with this option. So going with this one because that's what my question is asking. Similarly, I can find for the females also. How many females were there? 96. How many total female? 236. And then similarly, I can keep on going for this, for this. And you can see that conditional distribution here in the table. And then you can make side-by-side bar graph using this conditional percentage or proportion. And then you can say, and again, when you work on this, always make a key. And that key will tell what color represents what. So you can say that blue is almost certain, good chance, 50-50. So you represent different colors. And again, we are talking about categorical variables. So you can represent different colors. And then you can say that 4% is this. And then 11.6 is this, and keep on going. And then when you make side by side for male and female, you get a better idea that they are almost same here. Here, females are a little bit more. Here, like a little bit more, almost same, little bit more, and then you can compare that also. But again, the first thing that is important is this, the condition that is given to you. So go to the specific cell. First thing is go to the specific cell depending upon what the question is asking you, and then go to the representative denominator. Look for what am I looking for. This condition, I went male distribution of, calculate the conditional distribution of opinion of male. So I went to male and opinion. Since the opinions are so many, so I can do that. So I can go to the specific cell for each opinion. But what should I divide with? Am I looking for among all? If it says among all, if I'm looking for among all, that I'm dividing it with this. And if I'm looking for among males, which is the question, then divide with this. And if it says among the people for that particular opinion, then you are dividing with this. So now you have three choices in the denominator, and you need to pick the right choice depending upon what exactly your question is asking. And then examine the relationship between gender and opinion. And then that will give you more idea. Questions. So let's do an example. And again, as I mentioned, the examples are uploaded on Canvas in your Stat 108 notes. By the way, yesterday we uploaded a couple of documents in Chapter 2 regarding regression and correlation and two-way tables. It's in chapter 2 module. So take a look at that. And again, we are not forcing you to go over that material. That is extra resource that is helpful for you to understand the concept for correlation, regression, and two-way table. But if you think you don't have time or you have enough understanding of the chapter just by going through the lecture notes and attending the class, you are good to do that part also. You don't have to look, but just want to mention that there is more material uploaded on Canvas if you want to go over that. And since your test one is on chapter 1 and 2, so we want to provide you as many resources as we can. And you have a lot of resources, small stat tutor videos, concept chat, learning curve, all that material on your Launchpad as well. And I assign that again. It is not for the grade, but it is for your extra practice. If some concept is not clear, you can go there and watch those small tutorials, and that will be helpful. NTI 83, 84 technology manuals are also there on Launchpad. The information about chapter 1 and chapter 2, how to use calculator for specific concept is also given to you in Stat 108 chapter notes. We discussed that in class as well. So take care of that. And I think I mentioned a couple of times, and it's on Canvas also, that we offer free Math Health Center tutoring by our Department of Mathematics and Statistics. And those tutoring hours are also uploaded on your Canvas. Miss Minion also do the tutoring sessions. And since you all know her, and if you want to look at her tutoring hours, feel free to go. Mr. Philip is also there. He is also very helpful, and he has been doing this from past couple of semesters, so he kind of know the concept of our Stat 271, and he's pretty helpful too. So look at their tutoring hours and make sure just log during those hours only. And please do not send them emails, and just look at their Zoom IDs and their office hour or tutoring hour time and just connect during those hours. So if you look on Stat 108 chapter notes, small definition, or you can say the summary of two-way table is provided here. And just quickly look at the examples to understand what marginal distribution is, what conditional distribution is. And these examples are very similar like we just did on the slide. So here is an example. It says that how is the hatching of water python eggs influenced by the temperature of the snake nest? Researchers place some newly laid eggs in hot environment, neutral, and in cold environment. Hot duplicates the warmth provided by the mother python. Neutral and cold are cooler as when the mother is absent. The result is 75 hatched, 29 unhatched of the hot eggs, 38 hatched, 18 unhatched, and same thing 16 and 11. There are two categorical variables involved. So again, you will not get this part, the table that is provided in red. So just forget it for a second and read the question and try to see what information is provided to you. So we are given two categories, right? So environmental temperature as well as the hatching or not hatching of the egg. Once you have that information, how do you make a two-way table using those two categorical variables? And when you look at the question, this information is provided. If you look at the environment, you have three different environments provided: hot, neutral, and cold. And again, two type of results we have. One is hatched or unhatched. So, and it is also given that this is for hot, this is for cold, neutral, and this is for cold. So first of all, you need to make a two-way table. So once you know how many categorical variables are involved and what are the different labels, then you can make that. Then make a two-way table. So you make a two-way table, and this is nothing special, or it's not coming out from somewhere. It is coming from the information that we have. So I did environmental temperature, and the second one is hatched or not hatched, hatching of the eggs. And then hot, neutral, cold, and this information you have: 75 hatched, 29, 38. So once you are done with two-way tables, Then the question will be asked on conditional or marginal distribution, or the next topic that we have is Simpson's paradox. So this is the first step. Most of the time, table is provided to you, but if table is not provided, look for the information that is given to you and then make a table out of it. Questions. So once you make a table, like I mentioned, now create an extra row and extra column. Either you work with marginal or conditional. You need this for your denominator, right? If you are working with marginal, you need it for sure. And if you are working with conditional, you need your denominator that is coming out from this marginal extra row and extra column. So that was created here and the total was done. So 75 plus 29 is the same thing here. And 187, you can check. It is the sum of these three or the sum of these two. And if you add the row total and the column total and it's not same, that means there is something not right in our calculation. So we will go back and check our calculation. But your sum of row and sum of column should be same. And that gives us the idea that we are on the right track. We are doing calculation right. So that is the first step. Now, how is the hatching of water python eggs influenced by the temperature of snake's nest? And how do the hatching rate differ in various temperatures? So when we work with these type of problems, we call it a four-step process to solve a problem. And what is that four step? And again, you don't have to just go exactly the same way, but that makes your problem easier. First of all, state what your problem is. And then you plan your action, what you are going to do, what is given to me, and what I'm planning to do. Then solve. Again, solving basically you're showing the steps. What did you do? Are you working with conditional or marginal? And then what are you working to solve, or how you are solving those plan of action? And once you solve, this is the important part in statistic, and we are going to um, focus more on our later chapter 6 and 7, inferences. So again, when you take a conclusion, explain that in words what you have done from step 1 to 3 in simple language using the language of your question. Like if it says, explain this, and like it says here, how do hatching rate differs in various temperature, or how is hatching of water python influenced by the temperature of the nest, so snake's nest. So when you get the result, how do you interpret those results in word form instead of just leaving this is 20%, 30%, 50%, I'm done? No, that is not enough. Just finding these answers or finding these numbers or percentages is not enough. Now you need to write in words, what does this finding mean? What did you conclude? What is your result? So we call it a four-step process. And again, later on also we will learn what are the four steps process to write the inference. So here again, the conclusion is your four step. But we'll learn in later chapters also. We'll do inferences around the mean, inferences around the proportion. So we will talk about that in later chapter. But again, this is a important part. Now, let's see what is given to us. So, first of all, state what are the hatching rates in each temperature, each environmental temperature. So, first of all, we need to look at the hatching rate in each environmental temperature. When we are talking about each environmental temperature, so can we say that we will look at 75 divided with 129, 29 divided. So, number of egg hatched 75, and how many were total? 129. How many not hatched? 29 divided with 58. And similarly, can we keep on talking about 104 divided with 187? Or we can say like 38 divided with 129, 69 divided with 129. If I'm looking for this one, what are the hatching rates in each environment temperature? So hatching rate for hot is this, total is this, neutral is this, total is this, cold is this. And will it give me a reasonable comparison? So when we are talking about this, we know that just by looking at the numbers, if I just look at these numbers 75, 38, 16, and this is 129, do I need to do some math to find if which one is larger, which one is smaller? I can simply say 75 hot. Definitely there is more hatching in hot comparatively to neutral, and cold is the less. Then why I'm making this table and doing that? So when we are comparing, I need to see how many total eggs were hatched in hot temperature and how many total were not hatched in uh, not hatched in hot temperature. So I will compare that only with the total number of eggs that were placed in hot temperature. And then similarly neutral temperature and cold temperature. So this is not a good idea to compare just by looking at this, and divide with the total. Because here there is no point of doing that. I can see that 75 is bigger than 38 and 16 is the lowest. So I can just get the conclusion hot is more. So what I will do, first of all, I will look at, okay, so let's see the plan of action. So we can't compare this, and this to answer for this because there are different amount of eggs placed in different temperature level. In hot, there are 104. That's why I have a bigger number, and here 56 and 27. Therefore, we calculate the percentage of hatch from each of three different temperature groups. And then we will compare. So if we are looking for what are the hatching rates, so we will compare in within each temperature how much is the hatching rate when that many eggs were placed. So there were 75 eggs that were hatched out of 104, and I can look at that percentage. So 75 divided with 104, and again I'm multiplying with 100 to get the percentage, because percentages are easy to compare instead of just looking at the numbers in decimals. Same thing I can do for 38 divided with 56, and I get this, and 16 divided with 27, and I get this. So for the so this is how you solve. So in the solve process, you will tell what exactly you are doing to compare that. You may notice that temperature would be an explanatory variable, right? Because we are looking at how the temperature with the temperature. If my temperature is hot, what happened to the egg? Will it hatch or do not hatch? So that is my response variable. Hatching eggs are my response variable. And now you can see that for hot, it's 72, for neutral, it's 68, for cold, it's 59. So you can see that as the temperature is going down, your hatching is also going down. As the temperature gets small, temperature level gets lower. So as it gets smaller, so from hot to neutral, it goes down, and from neutral to cold, hatching also go down. Now the conclusion. The question is asking you, how do the hatching rate differ in various temperature, and how is hatching of water python influenced by the temperature of snake's nest? So now you take the wording from here and then write your conclusion. The data supports that the cooler temperature gave us less hatching. This is evident that as the hatching rate is associated with temperature, as the temperature increases, the hatching rates get more, and as the temperature drops, the hatching rates get lower. So this is called your four-step process. And again, it is good if you follow that four-step process, but if you look at your homework and quiz questions, there are no questions where you have to show a step-by-step process. This is for you to understand. And again, if there are questions in your exam, in your test, I will not expect you to write a four-step process there because of the time limit. Your exam is 50 minutes, and we have a 50-minute class. Right after our class, there is another class. So we need to complete our tests within 15-minute window. And if you are writing, let's say you have 3 questions or 2 questions on that, it will take a lot of time. But again, when you solve these problems by yourself, try to follow this 4-step process, because this will be very helpful for you to understand when you go back and check what I did. Oh, this was the part that was missing, so I need to go and work on that part. And there is another example. So let's paradox. So technically, we will be done with chapter 2 today, but we will take examples on Simpson's paradox on Friday's class. And your homework assignment is extended by another day and quiz. So homework is due on 14th and quiz is due on 15th. Excuse me. But do not wait until the last minute. It's already been extended, so make sure you work on that. And when we'll do the review on Monday, it will make more sense when you are done with your homework and quiz. And if you have questions from that, we can go over those questions in the class also. So there is another example. The popularity of computer, video, online, and virtual reality games has raised concern about the ability to negatively impact youth. The data in this exercise are based on a recent survey of 14 to 18-year-olds in Connecticut High School. And here are the grades distribution of boys who have and have not played video games. So the data is given to us, and it says that virtual reality games are raised concern, and it says that some students played games, some students do not played games, and they receive the letter grades of A's, B's, C's, D's, and F's. And on the basis of this, and again, we are talking about different categories of grades, A's, B's, C's. And now, how do I compare that and see if that really affect the negative? Is it really affecting the impact on youth, or is it not? On just the basis of this table that is provided to me. So once you have the table, you have two categories. One is grade average and another is games, or you can say the players who played or never played games. So we have two categories, and then we have in this category we have A's and B's, C's and D's and F's, and here played and never played, and then we are comparing that. So now, as mentioned, first create an extra row, an extra column. Sometime it's given to us, sometime not. So we will create that and then do the total. Once you're done with the total, now what do you need to do? You need to do your first step process: state, plan, solve, and conclude. So let's see what it says first. How many people does this table describe, and how many of these have played video games? Once you have a two-way table with the margins, you can find how many people were there altogether, right? So once you have the grand total, the total of sum of rows and sum of columns, you know how many players were there. And how many played games? I know played games. If I keep on following and look at that many played games. Not a big deal. I created my extra row and extra column, and I can find all those answers. How many students got A's and B's? Here. How many got C's? How many got D's and F's? How many never played games? Here. So this information I can find using my marginal distribution. Now the next. Give the marginal distribution of the grades. Now I have the marginal distribution. If I'm looking at the marginal distribution of the grade, I'm just going with this extra row and extra column with the grand total. So this 941 with 1808, 594 with 1808, and same thing here. And distribution of the grades. So A's and B's, how many? This. So that is for A, and that is for B, and that is for A's and B's, C's, and D's and F's. Questions up till this point? Now it says that what percentage of the boys represent in the table received a grade of C or lower? Since I calculated A's and B's, C's, D's, and F, and if you're saying C's or lower, so that means I'm talking about this part, right? So I'm talking about this plus this. So I know the percentage of C's, I know the percentage of D's and F's, so I can find that. I calculated here, right? So this is C's and this is D's and F. If you calculate this, you can find it. Questions? All right. If not, so let's go to the next question. We would like to draw the graph of the marginal distribution of grade. Should your percentage adds to 100? And you know that when we talk about categorical variable, you can make a pie chart or bar graph to represent your categorical variable. If your percentages adds up to 100, then you can make a pie chart. Otherwise, you will just make a bar graph. So this question is from your previous chapter 1. How many bars will be in the bar graph showing the marginal distribution of game playing experience? When we are saying game playing experience, so we are talking about this category, right? Game playing, played or never played. So when we are talking about how many bars, we get 1 bar for this and 1 bar for this. And the previous example in the slides that we did, let me quickly go to that one. Here, if we are talking about how many people, when we are talking about the opinion, how many bars we can make for the opinion, we can make 5 bars. 1, 2, 3, 4, 5. And how many bars we can make for gender? There are 2 bars. So same thing we are talking about here. So we can make 2 bars, and same thing if you need to make for grade average, you can make 3 bars, one for A's and B's, C's and D's and F. So for straightforward. To see the relationship now, when we are saying that to see the relationship, so we are talking about conditional distribution now. To see the relationship between grades and game playing experience, find the conditional distribution of grades for players and non-players. So now to find the relationship, if I'm talking about relationship, so for whatever I have done in the marginal distribution is not going to help me to understand the relationship. To look at the relationship, I need to find the conditional distribution. And again, if I need to find the conditional distribution, I need to go inside the cell. Here, 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 depending upon what I'm looking. So I can look at the conditional distribution for playing games when students score A's and B's, C's, and D's and F, and similarly for never played. And since it's here, so let me use this table also at the top. So you can see that also and see where these numbers are coming from. So when we look at this table, and we are looking for, we need to compare 2 parallel conditional distribution. And it says that it won't game playing experience is explanatory variable. So if we are looking like players, how many got A's and B's? 736. How many were there? There were 1,379 players. So I can find 736 out of 1379 scored A's and B's. Same thing, C's, and same thing, D's and F's. And then you can find their percentage. 736, 459, and then you see here, same thing you can look for player who never played. Now look at their percentage and compare. This is A's and B's, this is C's, and this is D's and F's. So if you look at the percentage, player who played scored 53% of them score A's and B's. Who never played scored 48%. Players who played scored 33% C's, which is less than A's and B's. And more people scored C's. And here 14% scored D's and F, but more people scored D's and F. So just looking at this data or this result, can we conclude that people or the subjects or the student who never played, they get impacted? Or who played, they get impacted and negatively impacted on the basis of this result? No, because here who played have higher A's and B's comparatively to who never played. So when I look at this chart, when I look at this table, or these number does not give me a convincing result that are they negatively impacted or not. But when I looked at this result, I can say that they are the player who played, they are not negatively impacted. In fact, they get better, right? So they are different, but not a big gap. So I cannot say that they are negatively impacted. So that means playing video games or doing virtual reality games are helpful to get better grades. That I cannot say that, but on the basis of this information, we just can say that it is not negatively impacted. And again, if you have to write, explanation or the conclusion, then you can explain that when you can compare parallel, and then you can write the result that A's and B's are higher, lower C's, lower D's and F's, so we cannot conclude that they are negatively impacted. And here again, it says that we would like to show the conditional distribution of grades for player using a graph. And we mentioned that we are talking about categorical variable. You can display categorical variable either using the bar graph or pie chart. For a pie chart, the sum should add up to one whole or 100%. Otherwise, you can use bar chart. And there are other questions here. What percentage of boys received C's, had played games, and how many received C's? You know that how many received C's here. So 594 is the total. And then what is saying? How many out of 594 boys, how many played games? And then you can calculate. So the people who received C's, how many people or how many subjects or how many students were there who received C's? There were 594. And how many of them played? So 76% receive A's and B's, and the other receive receive C's and that never played. And what would be we would like to compare the percentage of game players in each given grade group. So if you want to compare that, you can see that A's and B's, how many? So how many A's and B's were there? 736 out of how many? So 736 out of how many? 944, 941, same thing, 450 out of 594, 193 out of 273. And then you can find this. And then you can say that we can use only a bar graph because it is not a single whole. When you add all these percentages, it is more than 100%. So you cannot make a pie chart. You all only represent, if you are representing this particular, you can make 3 bars, one with A's and B's, one with C's, one with D's and F, and then you can represent this. But this adds up to be more than 100%, so we cannot make a pie chart for this. And we suspect that children played games are less successful in their grades than children never played. Does the data support? So I will suggest you to work on this by yourself without looking at the answer, and then go back and check. And if you think since the answers are already here, I will suggest you to look at this one. Just use this data set or use your own data set if you want. You can just take any of your data set and work, and then it will be helpful for you to understand the concept of conditional distribution. So conditional distribution, denominator comes from the margin. Either this or this or this. But in marginal distribution, both numerator and denominator comes from the margin. So marginal distribution, numerator comes from the margin and denominator also comes from that. Or you can say the denominator is the grand total, or sum of rows and sum of column, that also comes from the margin. But for conditional distribution, numerator comes from the cell. And again, what is a cell? Where we are looking for this plus this. So where we are, how do we get this 379? We cannot say this 379 is only the C's. This 379 is the C's for students who played games. So this is a cell which we cannot represent just using one thing. So student played games and received C's is this number. So your numerator comes from the cell and denominator comes from the margin. And that margin can be either the row total or the column total or the sum total. And again, I mean sum total means the sum of your row or column or the grand total. So those are the things that you need to know when we talk about marginal and conditional distribution. So our next topic is Simpson's paradox. And what is Simpson's paradox? So once we know our conditional and marginal distribution, then we can work with Simpson's paradox. And what is Simpson's paradox? In Simpson's paradox, when we work with two individual two-way tables, so we get some results from here and some results from here. But when we combine these two individual tables to make a big table, or the sum of these two tables, the results are reversed. Here, let's say I say that video games does not impact the students' results. But when I combine these two tables, my answer is it does impact. I use the same two-way table, just instead of taking two individual tables, I combine it to make it one. But my result is totally reversed now. So what I said here, it's totally opposite of that. And why is it possible? Because there is a lurking variable, and I mentioned lurking variable is a hidden variable that is neither in your explanatory, not in your response variable, but it is affecting your results. And when I'm saying it is affecting your results, it's changing your results completely. It's reversing the direction. So here what we conclude, here we are concluding totally opposite. And why? Because there is a lurking variable, and we will talk about this with an example in the next class. So let me just talk about the definition. When studying the relationship between two variables, there may exist a lurking variable that creates, and before you guys drop, just want to let you know that I will not be available during my office hours, but Miss Minion will be available. So if you have any questions, please log on to her Zoom ID at 11 o'clock, between 11 to 12, 11 to 11:45 actually. So if you excuse me, if you have any question that you want to ask me specifically, feel free to send me an email. But if you have any concept questions, then please log into Miss Minion office hours right after this class at 11 to 11:45. But as I mentioned, if you have any questions, let me know or send me an email, and I will answer your question. So when studying the relationship between two variables, there may exist a lurking variable that creates the reversal in the direction of the relationship when the lurking variable is ignored as opposite to the direction of relationship when the lurking variable is considered. So we will talk about this in detail in the next class, and I'll stop here. So if you have any questions, let me know. Otherwise, have a wonderful day, and I'll see you guys on Friday.
Thank
Thank you,
you.
everyone. Thank you.
Oh, I have a question.
Mhm.
So with the examples we just did, would that be kind of like what our test would maybe look like?
So your test will be very similar to your homework and quiz. So go over your homework and quiz nicely. And
Okay, thank you.
you're welcome. Hey, Million.
Hello.
So will that be okay for you to hold those hours?
Sure.
Yeah.
I'll leave my camera off, and if there's students, I'll just.
Yeah, because it's at 11 o'clock, so you still have time. So maybe you can join at 11 to 11:45, and
I can't join without you being here.
no, I said that join your office, your Zoom ID.
Oh, okay.
Do you think I should send an email to students?
You can.
Yeah, that way they know. Or I can leave my Zoom ID Zoom open.
Well, just tell them to join my session.
Yeah. So I will send the information. I'll send an email before I leave.
All right.
And I work on those questions. I will talk to you later on, maybe.
Okay.
Yeah, I worked on those questions. Like one question I did part, but I was not able to understand. And he added a problem, extra problem.
Yeah.
So we need to do that. But I am going to, I will scan all the work that I have done and send it to you from the campus so that you can take a look, whatever is, I kind of fixed the stuff that we discussed, but you can take a look. All right. I'll see you then. Bye.
Bye.
Bye.